All right, so today we're going to be practicing simplifying expressions of simplifying polynomials. So this first problem here, notice that we always want to check what operation's happening in the middle. And so in the middle there we have addition. Addition is nice and straightforward. It means we can go straight to combining like terms. So the first thing I'm going to do, I'm going to look at my problem. I'm going to see what degrees I have. So I have a degree of 1 here because it has an exponent of 1, a degree of 2, a degree of 0. I have a degree of 1, 0, 2. So my highest degree here is 2. So I'm going to go ahead and do is I'm going to start by combining the highest degrees. So I'm going to look for everything with a degree of 2. And since these are both the variable k to the exponent 2, I can go ahead and combine these. So I'm going to have, and I'm going to show you my in-between step of grouping them together. So I'm going to have 3k squared plus 5k squared. Okay, next, I'm going to find my next power. And my next one is a degree of 1. So I have 5k and negative 3k. So I can group these two guys together. And then I look for my last, and I have 6 and negative 2. So they can group together. And now I'm going to add those coefficients. My powers will not change, but the coefficients will. So if I have 3k squared and 5k squared, I'm going to have 3 plus 5, which is 8k squared. If I have 5k and minus 3k, 5 minus 3 is 2, and the k stays the same. 6 minus 2 is 4. Notice my final answer goes from an exponent of 2 to an exponent of 1 to no exponent. So this is now in standard form. And that's my final answer, 8k squared plus 2k plus 4. This is a polynomial with a degree of 2, because the biggest exponent's 2, with a leading coefficient of 8. Let's try another problem. All right, now this problem. Notice my operation in the center is now subtraction. If we have subtraction, we're going to have an added step to this problem. So our added step is we're going to have to actually distribute that negative. When there is a negative in front, you have to distribute the negative to every item behind the negative. So within the parentheses. So the negative multiplies to negative 3r cubed. It multiplies to negative 5, and it's going to multiply to negative r to the 4th. So I'm going to go ahead and rewrite it. So my first one stays exactly the same. There's no negative in front of it, so it stays the same. I want to turn this into an addition problem. So to turn it into an addition problem, I distribute that negative, which means I multiply it. So a negative times negative 3r cubed becomes positive 3r cubed. Negative times negative 5 becomes positive 5. Negative times negative r to the 4th becomes positive r to the 4th. So it ended up changing all the signs of the polynomial behind it. So now I can go to combining those like terms. So I look for my greatest degree, and my greatest degree is to the 4th power. So I have r to the 4th and r to the 4th. So these are going to go ahead and be combining. So I have r to the 4th and r to the 4th, and I'm going to group them together. Now, if you choose not to show this step, that is completely understandable. So you can go straight to the next step if you are comfortable enough with how we are finding these values. Okay, then I have 3r. Oh, that's not my next highest, so I shouldn't be using it. My next biggest exponent is cubed. And you could always just reorder into standard form at the end. So you could do that as a final step, or you can do it in the process like I'm doing here. Okay, so r cubed had nothing it combined with. So then I try to see, is there any squareds? And there's not. But there is an r. But there's only one r, so it's by itself. So that's going to tag on to the end. And then I go again and I look for my next like terms, and I have negative 2 and 5. Those two can group together. So I'm going to group those two together. Negative 2 plus 5. Now the ones that are grouped together, I'm going to go ahead and combine them. The ones that are grouped together, I will combine. So r to the fourth plus r to the fourth is 2r to the fourth, because I have 1 plus 1 is 2. Then I have my 3r cubed. I leave that alone. My 3r, I leave it alone. And negative 2 plus 5 is positive 3. So my final answer is a fourth degree polynomial with a leading coefficient of 2. Again, notice none of my exponent powers change through addition and subtraction. Next problem. All right, so this time I have a binomial times a 4-term polynomial. We apply the same rules. I look and see what sign is in the middle. It's addition. So it's straightforward. I just start combining like terms. When it's addition, I'm just going to go straight to combining like terms. So I'm going to go through and look at what my greatest degree is. And my greatest degree is fourth. So I try to see if there's any other fourth degrees. And those two are going to group together. So I'm going to get 8x to the fourth plus x to the fourth. Then I go through and I look for my next greatest power. And that's going to be 3x cubed. There are no other x cubes in this problem. So I'm just going to add that on by itself. I look for my next greatest power, and that's negative x squared, but there's nothing to combine it with. Then I go through and I look for my next greatest power, and that's my constant. So I have 8 and negative 8. So those two are both constants, so they can group together. And so now I'm going to go ahead and simplify this. I have 8x to the fourth plus another x to the fourth. Remember, that's a coefficient of 1 when you don't see it. So 8 plus 1 is 9x to the fourth. 3x cubed minus x squared. And 8 minus 8, that's just 0. If it's 0, I'm not going to write it in for my final answer. So now I have a polynomial with a degree of 4, because the biggest exponent is 4, and a leading coefficient of 9, because the coefficient of the term with the greatest degree is 9. All right, let's try another one. This time it's subtraction. Okay, so notice subtraction. So anytime you see subtraction, you need to multiply that negative to the polynomial behind it. You need to multiply that negative to the polynomial behind it. Every term in the polynomial. So notice there are 3 terms, so every term will be multiplied by that negative. So my first polynomial I'm going to leave alone. It's not going to be affected. So it's going to say 6x to the fourth minus 7x minus 6x squared minus 3. I'm turning it into addition by distributing that negative. And so my next polynomial now, the negative 7x becomes positive 7x. The negative 8x to the fourth becomes positive 8x to the fourth. The negative 1 becomes positive 1. So distributing the negative changes my signs. And so now I'm going to go to combining like terms. So I have 6x to the fourth and I have 8x to the fourth. I'm going to go ahead and combine these. Okay, I don't have anything with a degree of 3, so then I'm gonna go ahead and go to a degree of 2. There's only one of them. So I get minus 6x squared. Then I'm going to look for my next, and I have negative 7x, and I have positive 7x. So I have negative 7x and positive 7x that I'm going to group together. And then I look for my last one. I have 2 constants, negative 3 and positive 1. They're going to group together. And so now I just combine my like terms. So 6x to the fourth plus 8x to the fourth is 14x to the fourth. The negative 6x squared comes down. Negative 7x plus 7x, that's just 0, so it goes away. Negative 3 plus 1, that's negative 2. So my final polynomial ends up being a 4th degree polynomial, because my biggest exponent's 4, with a leading coefficient of 14. Notice all my answers are being left in standard form, from biggest exponent down to the smallest. Let's try one that has 3 polynomials. Let's add or subtract 3 of them. Now notice this time I have a couple different operations happening. I have subtraction here and addition here. I want to change this all into addition. So to change it all into addition, I'm going to distribute the negative, but the negative will only touch the first set of parentheses behind it. So this negative will distribute to the negative 7v squared, to the 4, to the 6v cubed, and to the v. It will not touch this next parenthesis, so it only distributes to the first set of parentheses it's touching. So I'm going to go ahead and rewrite. And so my first polynomial I leave alone. I'm turning this into addition. And so now I have positive 7v squared plus 4. It is not plus 4. I distribute the negative. And so negative times positive 4 becomes negative 4. Negative times 6v cubed becomes negative 6v cubed. Negative times v becomes negative v. And then my next polynomial, I leave the same. So that last polynomial stays the same because it's already addition. So I only change the sign when there's subtraction. And now I'm going to go ahead and start grouping like terms. So I'm going to go through and look for my greatest exponent. And my greatest exponent is cubed. So I have 2v cubed, I have negative 6v cubed, and I have 7v cubed. So I can combine all 3 of these. So I'm going to get 2v cubed minus 6v cubed plus 7v cubed. All right, next, I look for any squares. And I have 7v squared and negative 7v squared. So I'm going to combine these. All right, next, I have negative 6v, negative v, negative 3v. So I have 3 of them to combine. Negative 6v minus v minus 3v. And then last, I have this negative 4 hanging out. So negative 4 is just going to go on the end by itself. So notice I went from biggest exponent all the way down to no exponent. So now I'm going to combine my like terms. 2 minus 6 is negative 4. Negative 4 plus 7 is 3. So I'm left with 3v cubed. 7v squared minus 7v squared, that's 0v squareds. If I have 0 of them, I'm not going to write them. Negative 6 minus 1v makes negative 7. Negative 7 minus 3 is negative 10v. And then my minus 4 adds on to the end. So that's our practice with adding and subtracting polynomials.